Okay, so what happens if you want to calculate the electric field due to two charges? So in that case, there's a very fundamental idea about electric fields, and that's that you can't cancel electric fields. I mean, you kind of can, but electric fields at any particular location is the sum of the electric fields due to all the charges. We call this the superposition principle. So that means that if I have two charges right here, and I want to find the electric field right there, I find the electric field due to this charge right there, plus the electric field due to that charge right there, and add them up as vectors. That's important. You have to add them as vectors. So let's just sketch that. So these are both 5 nanocoulombs. This one's at 0.2 on the x-axis, this is at negative 0.2 on the x-axis, and this is at 0.2 on the y-axis. So if I want to sketch the electric field due to this one, it would be pointing directly away since it's positive. I'll call that E1. And then this one is pointing directly away, E2, like that. And then I'm going to add those two together. So I'm going to find each individual electric field, and I'm going to add them together and then be done. So here's my expression for the electric field, K, Q, R hat over R squared. So again, the first thing I'm going to need to do is find R. Let's deal with E1. That's a vector. So I'm going to find, I'll call this R, I called that one R1. R10, how about that? This is going to be R observation, or which I call just RO, minus R1. So I want this, actually I called this 1, and that 2. So I want the vector from this point charge to that observation location, and that's R. So this is R1, this is RO. The difference between those two is this value R, which I'm calling R10. Okay. So let's just write this out as R observation is 0.20 minus negative 0.200. So I see, and I left off the units. But when I put things in component form, it's easy to do the subtraction because I can say 0 minus negative 0.2 is what? It's 0.2. 0.2 minus 0 is 0.2. And 0 minus 0 is that. And so you see here, it's a vector in the positive x and the positive y direction, which is exactly what we have. Be careful here, because we're subtracting a negative. Remember, that's like adding, right? Okay, so I have the R vector. Now I need to find R magnitude. So I'm going to say R10 magnitude is the square root of 0.2 squared plus 0.2 squared plus 0 squared. Square root it. And it will be in meters. And I'll leave that there because I'm not going to get into all the details. Now I need to find R1 hat. R10 hat. It's going to be R10 divided by the magnitude of R10. So it'd be this 0.20 meters divided by the square root of 0.2 squared plus 0.2 squared square rooted meters, and you see I get a unitless vector, a unit vector without units, which is what I want. Now I can plug things into this equation, right? But this is a vector, that's a scalar. I'm all set. Okay, so E1, it's going to be K, 9 times 10 to the 9th, leave off the units. Q, 5 times 10 to the negative 9th. R hat, I guess I should put in, I should have calculated this out, shouldn't I? Let's just leave it as R hat over the magnitude of R squared, which is going to be 0.2 squared plus 0.2 squared. And if I do that, I get the following vector. You can check your work here. 397.7, 397.70 newtons per coulomb. So the electric field is in the positive and x direction and the positive y direction. That's important. Okay, Now, since I'm on a dry erase board, I can actually do some magic here. What if I want to do the exact same thing for E2? Well, everything's pretty much the same. I only need to change a couple things. So let's say E2, R20. So I'm changing R2, which is now that's positive. So that's going to change this to 0 minus 0.2, negative. You see that? Now, R20 magnitude is the same thing. Because I squared that negative number, it doesn't matter. R20 hat does change because there's a negative sign right there. So up here, E2, this is R20, but everything else is the same. So the only thing that's going to change is the sign of this x component, and I get E2 equals negative 397.7 397.70 newtons per coulomb. Now E total is E1 plus E2. Notice here, since this has the exact opposite x component as that, when I add them together, canceled. Okay, so I'm not going to get an x component. I'm only going to get an electric field in the y direction, and I get, so 397.7 plus negative 397.7 is 0. And then 397.7 plus 397 is 7, I round it to 795.5. And then 0 plus 0. And then that is my answer.